How are you guys? Welcome to Memo's Tutorials. Today we are looking at the scientific method where we are saying here we have steps of the scientific method. Here on these steps we are saying in most cases ask a question. The scientific method starts with a question about something that you observe. It can be in the form of how, why, when, what, or where. So here you have to construct a hypothesis. So a hypothesis, we are saying this is an educated guess about the outcome. And when you are making this educated guess about the outcome, you must state your hypothesis in a way that you can easily measure or test. It mustn't be, it's an educated guess. You are guessing, yes, but then you are not guessing far from the truth. You're not giving just a random guess. Ne? You are looking, let's just say maybe you are looking at the effects of temperature on the enzyme activities. Ne? Your guess can be, as temperature increases, the enzyme activity may increase, or the enzyme activity may decrease. So I'm sure you have, looking at this example, I said it's temperature and enzyme activity. These are two variables. And in my hypothesis, I'm including both the variables. Take note of that. So as you mention your hypothesis, it must include both the dependent and the independent variable and the relationship between the variables in your hypothesis. Ne? My variables in this case is temperature and enzyme activity. And temperature is independent and enzyme activity is dependent. And in my hypothesis, I'm saying that as the temperature increases, the enzyme activity also increases. I've mentioned both variables, and now I've said the relationship that as temperature increases, enzyme activity also increases. This is my guess, this is my hypothesis. And then after you have done your hypothesis, the next thing, test your hypothesis by doing an experiment. Now you're doing the actual experiment, and then you're going to observe and see whether your hypothesis, is it close or is not close, is it correct or not. But remember, a hypothesis is never wrong, though, but your guess has to be in the range. Okay, so your experiment tests whether your hypothesis is true or false. And it is very important for your experiment to be a fair test. I'm sure in grade 9 you did this thing of fair test, even in grade 7 as well, in natural science. Also, you conduct a fair test by making sure that you change only one factor at a time while keeping all the other conditions the same. That's very important when doing an experiment. You should also repeat your experiment several times to make sure that the first results were not just an accident, if possible. So doing an experiment more than 5 times or many times, it increases reliability. Your results become more reliable. Okay. And then the next thing is variables. Remember, we said we have got the independent variable and the dependent variable. So the independent variable, we are saying it's a factor that you choose to control in the experiment. This one you can control. And then the dependent variable, we are saying it is a factor that you measure in an experiment. It's the one that you measure, but then the independent is the one that you can control. And another important thing here, after all this experiment, at the end of the day, you can be asked to draw a graph. So just know that the independent variable goes on the x-axis and the dependent variable goes on the y-axis, just a reminder. And then we have got fixed variables. These are variables or factors that stay the same throughout the experiment. Are we together? They remain the same throughout the experiment. That's why we say they are fixed variables. And then in each and every experiment, there's an aim. Sometimes they can give you an investigation and they don't tell you the aim. They can ask you, what was the aim of this investigation? So answering such questions, you should say, aim to determine or to investigate. To investigate what? You must mention the two variables that are involved. In today's lesson, I gave an example of enzyme activity and temperature. So we can say the aim is to investigate the effect of temperature on enzyme activity. I've mentioned temperature, another that's a variable, and enzyme activity is also another what? Variable. We must take note of that. And then we have apparatus. These are a list of the apparatus it can either be chemicals or the equipment that we use in the experiment. So in some cases you may be asked to draw the apparatus as it should be set up. So you must be familiar with apparatus to say, if I'm to test a leaf for starch, which apparatus am I using? What maybe it's simple distillation or whatever it is, you must know which apparatus we are going to be using in that particular experiment. Another thing is method. The method is written in steps and is numbered. So it is short and simple and written in third person as a set of instructions. I'm sure this one is straightforward. It's instructions on how the experiment must be conducted. And then after an experiment has been done, we have results or observations. So it can be in the form of a table. A table can be used to record results. The observations can also include what you have seen, heard, or smelled. Sometimes there's sound produced, sometimes there's a certain odor produced, or sometimes you can see some things happening, like effervescence, maybe there's a gas that comes out, that smoke and all those things. And after that, you may be asked to draw a graph showing the results. And then we have discussions. Under discussion, you state the results, you discuss the results, telling us why it happened and what caused it to occur, and was the hypothesis true or false. Now you are comparing what you observed with your hypothesis, with your guess. Was it a fair test? You tell us, was it a fair test? And how could you have improved your results? So all these things, they fall under the discussion. And then lastly, we have conclusion. The conclusion, you refer back to the aim. So the conclusion, it is a short statement. You don't write a lot of things on the conclusion. Remember, the aim in this experiment, we are saying to investigate the effect of temperature on enzyme activity. What would be the conclusion? Maybe the conclusion could be, as temperatures increase, the rate of enzyme activity increase up to a certain point. After that, it starts decreasing as enzymes will become denatured. That can be what? Your conclusion. Your conclusion is not too long. We don't expect to see 4 or 5 lines of the conclusion. 2 lines maximum, it's your conclusion. And then they like asking questions on reliability. How can we increase reliability? Were the results reliable? So reliability of results can be increased by repeating the investigation. Repeat it as many times as possible for you to get reliable results. Also, you can increase the sample size. The larger the sample size, the more accurate the results. And then we have validity. Validity questions how the investigation or experiment or method was carried out. It is very important to be sure that all the factors or variables have been controlled except the one variable that is being tested. So every other thing has to remain constant, has to remain the same. Only the factor that we want to investigate is the only one that is going to change. So if you make sure that all the other factors were maintained, were constant, then we can say our results are valid. But if there's some like the irregularities, to say in this case 2 factors, 3 factors, some of the things changed, then your results we can say they are not valid. So you must make sure that as you conduct your experiment, you are only effecting a change on one factor, not many factors at once. Otherwise, your results will not be variable. To ensure validity, the samples must be chosen randomly as well. Just choose the random samples. It will increase the validity of your results. That's all for today's lesson. On our next lessons, we are going to be looking at calculations, where we'll be looking at averages, percentage increase, ratios, and also magnification when given work you are under the microscope. So for that one, I'll need a board and write on the board to show the calculations. And then after that, the next thing that we are going to look at is biosphere to ecosystems, which is week 2. So in other words, we are 95% done with week 1's work for grade 10 life sciences. I hope this is helpful.